Good morning and welcome to this edition of Generación STEM Get Future Ready live stream. My name is Marifer Zavala, graduate assistant for Generación STEM at Texas State. I'm so excited to be back for another Get Future Ready session. This week, I am joined by a very special guest, Mr. Manolo Alvarez, systems architect at Dell Technologies. Mr. Alvarez, it's a pleasure to be able to chat with you today about your work as a systems programmer at Dell Technologies.
Thank you. It's great to be here.
Definitely. Before we get into the more technical part of this conversation, will you please give us a bit of background about yourself?
Sure. I am originally from Guadalajara, Mexico. I was born and partly raised there. I moved to Brownsville, Texas when I was about 10 years old. I went through middle school and high school there, graduated in 2017, and then came to Austin to start my undergraduate at UT in electrical and computer engineering. My first freshman year, I spent it adjusting to the climate and the school and the environment. My freshman summer, I studied abroad in Japan, taking a class in nanotechnology and entrepreneurship. Came back, started looking for internships. I went to the SHIP National Conference and I was able to land an internship there at Boeing over in Seattle, Washington. So the following summer, my sophomore year, I went to Seattle. I was a cabin and network systems engineering intern. So I worked essentially on the electronics that go in the in-flight entertainment system. So anytime you see a panel, like a screen or the AC outlets on the planes, my team would have worked on that. I didn't love the job, so I came back to UT and started looking for other roles for my next internship. I interviewed and landed a job at Dell as a system architect. And so my junior year, going into my senior year that summer, I interned at Dell. I loved my time there, my job, the people. And so thankfully I was extended an offer a week after my internship and I accepted that and then started working full-time in May of 2021. So last year, actually July, I graduated in May. And then throughout my undergrad, I also did a minor in business. And then just recently, I started a part-time master's program at Stanford in electrical engineering. That's my background.
Thank you so much for sharing. And we asked you to be here today because we want our students to learn more about career opportunities that are available for them to explore after they complete their STEM career at Texas State. Can you tell us a little bit more about your job?
Sure. I'm a system architect. I don't program, but I'm more on the hardware side, on the electrical engineering side. You can think of an architect similar to what a real architect that architects houses does, but more on the product side. So I work on product development related to some of our notebooks, tablets, two-in-ones that Dell offers. And so if you can, what we do in our role is essentially we look at, okay, what kind of 2 years ahead of market, what do customers want, right? What kind of experiences are we trying to enable? And customers typically want the thinnest, lightest, coolest, fastest system they can get and a good price. And we try to find a balance amongst those. So we interview people, we look at trends, and then we start to think, okay, what can we do 2 years ahead? How can we architect this system such that it's fast enough for the customers, it's a good price, it's thin, quiet, and it performs better than the competition, right? What the competition offers. And then we look at technology trends and what kind of technologies can we bring into our systems. And so I typically work with a mechanical engineering counterpart. So I'm an electrical engineer, mechanical engineer, and together we architect the system. My mechanical counterpart works on the assemblies I work on the electronic design, the circuit design, any kind of circuitry that goes on the system. That's my bread and butter. And then we work with a core team, that's a marketing team, procurement, sales, our development team in Taiwan to essentially develop the system together and iterate over our ideas, right? And so I have here one of our systems opened up, and as you can see, once we settle on specific features that we think are going to enable certain experiences or the right experiences for our customers, we start to think, okay, well, we want this much power, for example. Well, we need this big of a fan to cool the system. And so because we need this big of a fan, this is how much space we have for the circuit board that goes on the system. And we have this much of this big of a battery. So this is how much space we have, right? And so I start looking at, okay, well, this is how many components I need, which ones I need. As you can see, there's thousands of them. And I start thinking, okay, well, how can we place them such that they are least prone to failure, and so that's such that the circuit is as tight as possible? Because that in the end, that's actually that's better practice, and it's cheaper. So I start looking at that so I do floor plans, I play around with the placement, and then after I'm comfortable with the placement, I start looking at ways to route each component, which is essentially connecting each piece together. I do that for a little while until I'm comfortable that what I'm proposing is doable. And then I do that on a tool called Cadence Allegro. Once I get to a point where I'm comfortable with it and, we're comfortable with where everything's placed, what we're able to enable with this placement, then we start engaging our Taiwanese teams, our partners, and start actually developing and building this thing. And so that happens for maybe a couple months. That's when I start phasing out of the project, but I'm still somewhat engaged. So I sit in meetings every week. I meet with them, and then we start talking about, hey, what's the progress? What kind of tests have we passed, failed? And how do we want to act based on how those things passed or failed? And we get prototypes. So this was one prototype. I have a lot of them at home. So that's probably one of the cool things. You get prototypes, you're able to try them, test them, and then you're able to tear them down and just keep them if you want, or just use them for whatever purpose you want to use them for. That would be what we do on a typical program. And so there's iterate product life cycles. So every year or so we alternate products. So then I start working on the next generation of products. And as we're doing that, we're still looking at technology. So what kind of displays are going to be available by then? What kind of battery chemistries are going to be available by then? How good are the processors going to be by then? And we start looking at those in advance, and those things change often. So that's one of the things that also makes our work challenging, is that it's a very fast-paced environment in that technologies change often. So we have to adapt ourselves. We have to constantly learn new things, and so we can stay relevant. But then also, because technologies change, some technologies that we thought were going to be ready in a year are not going to be ready, or some features that we didn't think were going to be ready are ready. We have to adapt our solution, and we have to make those decisions quickly. And so that's what also makes our job a little more complicated, but fun. It's like there's always a challenge, always a problem to solve. We're always collaborating with not just our engineering teams, but the marketing, sales, procurement, and we're trying to find the best solution forward, right? And so that would be in a nutshell kind of what I do. Honestly, no day is the same like this. I don't wake up and I know what's going to happen. I have a set of tasks I want to accomplish, but things always come up, meetings come up, and you just got to address those. Yeah, that would be my job in a nutshell.
Well, thank you for showing us the model. It sounds like a really creative role. And I can tell that you really enjoy doing this. So thank you for inspiring our students. Can you also tell us what steps you took for your professional role?
Yeah.
To prepare for your professional role?
Yeah. I can't say I planned it ahead. Um, I obviously took my classes, and what happened is I explored and I got involved in different technical organizations, and I had these internships, and it was through those experiences that I kind of ended up moving towards this role and knowing that I wanted to do this long term, or that I would enjoy this job long term. So I wasn't always just preparing myself, but I guess there were things I did that did help me um, land this job, but also be successful in my current role. And that's, you know, taking, I wouldn't say the class specifically, but definitely working on the technical skills and also soft skills. And so I, there were some classes that helped me on the technical side. So there was like circuit theory and power electronics and computer architecture. I don't think they're the end all be all. Like if I hadn't taken those classes, I wouldn't have been landed this job or been good at it. The expectation coming in isn't that big. Like a lot of things you learn on the job, but it definitely informs your decisions, and it's just good background to have. Um, that would be on the technical side. On the soft side, I always involve myself in some leadership organizations. So I was heavily involved in SHIP at UT, and so through that, I was able to take on some. I was professional director, and so I led a lot of our professional workshops, and that got me exposure to companies, and so I was able to enhance my skills talking to like, professional communication skills, and then just improving my emotional intelligence, and then just leading a team and getting stuff done. And so those sort of things that are definitely very useful in an engineering and non-engineering role. And I think those are the things that I did that have helped me be where I'm at and just be good where I'm at.
Sounds great. And we already touched base on this, but I want to ask you, if a student was considering this career path, what things can they do while they're in school to better prepare them for this type of role?
Yeah. If for this specific role, I would say taking, as an electrical system architect, I would say taking some power electronics classes, circuit theory, and computer architecture, embedded systems classes, getting involved in technical organizations that do some of that. And then if you want to be a mechanical architect, for example, then just doing some CAD designs and getting involved in some innovative challenges like product design. I don't know. And I would say that, and then also, like I mentioned before, just enhancing your soft skills. Like you can be really good technically, but if you can't communicate your results, if you can't tell me what you're working on or why what you're working on is so revolutionary or so great, then what's the point? I'm not going to catch that. No one else is going to catch that. And then you're not going to be rewarded for it. Or your idea may not even go through the pipeline to development. So I would say, to answer your question, definitely take those technical courses I mentioned, or try to take them, or just read up on them, read a book, right? Do some circuit design, PCB circuit design, if you want to do my role. But then also, then this goes for everyone, is like enhance your communication skills. Read, write, and then just make sure you're putting yourself on the spot and trying to do a little bit of public speaking or just lead some teams. And that's going to not only make you a better candidate, but also it's going to help you in the long term.
Thank you. So from your perspective, the skill set that you think is the most important for students to prioritize would be developing good communication skills outside of the classroom. And is there a particular professional skill that you would emphasize that is important in your line of work besides the one that you mentioned?
Um, I somewhat touched on it. Yeah, so communication, but also the ability to drive. So I have to drive a lot of teams, especially in Taiwan, and so just yeah, the ability to drive, gather people, and get stuff done. Like make sure that it's something. There's an action item after every meeting, or just making sure that you're pinging the right people to get their stuff done, or make sure that you're looking at the big picture and you're like, okay, there's a gap here. No one's working on that. Someone should be working on that. I'll work on that. Someone should be working on that, but catching on to that. And not being afraid of just, you might be starting out of college and just doesn't matter. Doesn't make you any less relevant, or doesn't make you any worse of an engineer than your peers. Like you don't fall into that syndrome. I forget the name. the syndrome where you don't feel like you belong or you can't do it, right? And so yeah, and you can kind of hone in on those skills in college while in those organizations. I did it through SHIP. I also did it through the undergraduate advisory board at an electrical engineering department. And so that would be my one tip there. There's also emotional intelligence. So that's essentially your ability to understand and use and manage your emotions in positive ways to like relieve stress, communicate effectively, and empathize with others. And that's gonna it's harder to train, but the more you work with people, the better you're gonna get at those skills. And you want to make sure you're a good team player, because in the end, you're working on something. You're always going to be working on something together. And so while you may think, and you can't do it all yourself, so you want to make sure that what you're doing and how you're controlling your emotions isn't affecting the team overall. And like I mentioned, writing, just do some kind of writing every now and then. That's going to help you write more, communicate more effectively.
Thank you so much. So if you guys have any questions, you can go ahead and post them in the chat. If not, I can ask you a little bit more about what was the hardest part about transitioning to the workforce after graduation?
Yeah. There was a big learning curve starting off. I would say that was probably the hardest part, but what didn't make it so hard in the end was that I had the right mentors with me. I always had people I could ask questions to and rely on to kind of explain to me or just help me out if I ever need help. That's what made it the hardest, I would say. But then also just time flies more when you graduate. So just making sure you're managing your time accordingly, you're prioritizing things. And thankfully, Dell has a good work-life balance, or promotes a good work-life balance. And so that hasn't been an issue for me, but making sure that you just have your priorities straight. And aside from that, it hasn't been too much of a struggle, really. Now, one thing that you only realize when you're in college is that, in college you have like a 6-month class, and you know what the deliverable at the end is. You know where you're headed towards in 4 years or 3 years or 2 years. You're graduating, right? But when you start working full time, it's like you have a whole career ahead of you, and how you plan that is a lot more complicated. And I don't think anyone is able to plan it the right way the first go around. A lot of times your interests change over time. What you think you were going to be able to do, you're no longer have the time for, or your project changes or whatnot. So you just got to adapt. But yeah, I've learned that. I wouldn't say the hard way, but I've learned that over time, and you get better at it. So.
Yes. Well, Mr. Alvarez, thank you so much for being here today and helping our students learn more about your career and possible ways to prepare for entering the STEM workforce.
Yeah, I was happy to be here and talk to you all. Thanks for the questions, and good luck to everyone.
Thank you all for joining us today for this edition of Get Future Ready. Have a great day and see you next time. If you're a student at Texas State working towards a career in STEM, please reach out to us so that we can help you navigate your STEM career development at Texas State. You can find us on social at Texas State Gen STEM. Thank you.